Now we go to this example 2. We want to find the equation of tangent line. So this question asks us to find the equation of tangent line, not just gradient. Remember, we have 3 steps before. To the function of this fx at point x equal to 2. So when we plot this function, we'll got the red color curve. Okay, but for x equal to 2, it is, for example, somewhere here, means that it is a tangent line which is given by this blue color of line. So how to compute this? We need to use quotient rule because we have a division of two functions. In this case, how to differentiate dy dx? Use quotient rule. Okay, quotient rule given by formula dy dx equal to v u prime minus u v prime divided by v to the power of 2. So before we differentiate this function, we need to identify first which one is v, which one is u. So in this case, the numerator here is actually u, and the denominator is v. So here we have u equal to 4x squared plus x minus 2 and v equal to 2x minus 1. We need to find u prime and v prime, and then we can substitute in this dy dx. Our u prime is given by 8x plus 1. It is simple to differentiate. And v prime equal to 2. When we substitute in this dy dx, we have our dy dx equal to, when we substitute in dy dx, we have here vu prime. So it is 2x minus 1 times 8x plus 1 minus u, which is 4x squared plus x minus 2 times v, which is v prime, which is 2, divided by v squared. So 2x minus 1 squared. In this case, no need to expand this one and no need to simplify this function. Okay, if you remember, this is our step number 1. We need to differentiate function. And step number 2, we need to substitute x in dy dx. So in our case, our x equal to 2. When we substitute this x equal to 2 in dy dx, we will have here dy dx equal to 2 times 2 minus 1, 8 times 2 plus 1, minus 4 times 2 to the power of 2 plus 2 minus 2 times 2, divided by 2 times 2 minus 1 square. So when we solve this one, we'll got the answer which is equal to 19 over 9. But it is not yet finished, because this question asks us to find equation of the tangent line. Now we got here a slope. So our step number 3 here, we need to substitute the value of a and b, also our gradient into equation y minus b equal to mx minus a. M is given by this dy dx. But what is the value of b and a? A actually is the value of x. That is here is 2. So in our case, a equal to 2, m equal to 19 over 9. But for this b, how to get this b? This b actually is y value at x equal to 2. Remember, it is y value at x equal to 2. So we have originally this one is our function from question. So how to get the y at x equal to 2 means that you need to substitute this value of 2 in this original function. That is here, our y will be equal 4 times 2 square plus 2 minus 2 divided by 2 times 2 minus 1, which is here, the answer is equal to 16 over 3. So this is equal to B value. So when we substitute all the values that we already have, we have here y minus b, which is 16 over 3, equal to 19 minus 9 x minus 2. So this is our equation of tangent, or we can simplify this one, which is we can get here, it is 9y equal to 19x plus 10. You can leave your answer either in this form or either in this form. Doesn't matter, you still can get the same marks. So now class, we go to the third question. The third question actually involves implicit differentiation. So this question asks us to this question asks us to find the equation of tangent line for the curve of x squared minus 4xy plus y squared equal to 3. And now we have a point 1.732 and 0. And remember, this one is our A and this one is our B value. Okay, our first step, we need to find first dy dx. So to compute dy dx in this case, you have here quite complicated function. So you need to differentiate both sides. Okay, we need to differentiate both sides. Means that here what we need to do, we have to differentiate, okay, x squared minus 4xy plus y squared equal to, we differentiate this side, which is differentiate 3. And then when we expand this one, means that we differentiate here x squared minus 4, we differentiate here xy plus differentiate y squared, and when we differentiate constant, we'll got the answer equal to 0. And how to do this? You can see you have x and y in this equation. You need to use here implicit differentiation. Okay, you can refer to my additional note on how to use implicit differentiation for finding a derivative of function. So in this case, it is okay because we just have x squared here. So we differentiate it like we differentiate dy dx as previous example. So what we did here, we can get the answer 2x minus 4, but this one we have two terms, x and y. So now for this one, when you differentiate, you have to use product rule. Okay, what does it mean by product rule? Product rule given by, when we differentiate function, our f prime x equal to uv prime plus vu prime. This is product rule. So in this case, when we want to differentiate this one, we need to identify, let's say u equal to x, v equal to y. This one just for this part only. And then we differentiate u prime, we got equal to 1. But when we differentiate y, we got it is dy dx. So in this case, when we substitute in differentiation formula, we have here uv prime, that is x dy dx plus vu prime, y times 1. So this is the answer for this part. And then we have here, when we differentiate this one, we'll got plus 2y dy dx, which is equal to 0. For this part, we will got this answer. We differentiate here, we differentiate 2y, and then you need to differentiate again this y. So 2y times dy dx. When we expand this one, or we simplify this one, we got 2x minus 4x dy dx minus 4y plus 2y dy dx equal to 0. Now, we need to rearrange this part such that dy dx become subject. So, we'll have here negative 4x plus 2y, this one, this term, and also this term times dy dx, which is I factorize this part, okay? And then for this one we move to this side, the term where there is no dy dx, 2x and negative 4y, we move to this side, we'll got here negative 2x plus 4y. So in this case, we will have here our dy dx will be equal negative 2x plus 4y divided by negative 4x plus 2y. And then from here, we can substitute this is x value, this is y value. Substitute all these values in this function. We have here, this is our step number 2. dy dx equal to negative 2 times 1.732 plus 4 times 0 divided by negative 4 times 1.732 plus 2 times 0. We'll got here the answer equal to 1 over 2. And then, once we got this gradient value, we can substitute in formula, which is we have formula y minus b equal to mx minus a. That is here, we already have b and a. We don't have to compute, so y minus 0 equal to our m is given by this dy dx. That is 1 over 2 x minus 1.732. Which is y equal to 1 over 2x minus 1.732. So this is the final answer for this example 3. So class, now we come to the end of week 13 part 1 video. See you next in week 13 part 2 video. Thank you for your attention.